Day 98 notes, Advanced Algebra 2. Yesterday's discussion about domain and range was a more mathematical discussion. It was more of a discussion on the pure behavior of graphs and acceptable limits for graphs rather than a look at the applications of such. Well, today we're going to look at the applications of the behaviors of some of our graphs. And what we're going to spend our time looking at are average rates of change, or in other words, slopes of linear equations. Now, an average rate of change is the slope between 2 points. And I can establish 2 points with coordinates. So if I have a point here and a point here, and if this one is at an x value of -2 with a y value of 3, and this one is at an x value of 6 with a y value of 8, I can calculate the slope between these two. I can figure out what the rise and what the run would have to be in order to reconnect them. Now, slopes of lines are really important to us when we're dealing with linear equations because they are examples of functions with a constant slope. The slope doesn't change. And when we see this equation, y equals mx plus b, slope is the letter m, that's our rate of change, and b is our y-intercept, or it's our starting point of the graph. There is an equation that we can use to calculate the slope between any 2 points. And that equation is this: y2 minus y1 divided by x2 minus x1. As mathematicians, we use these little subscripts, y2, y1, x2, x1, to represent different values for an x value of a coordinate and a y value of a coordinate. So if I'm asking about y2, that should be the y value from the second coordinate. If I'm talking about y1, that's the y value from the first coordinate. Oops, let me get this squared away here. Y value from the first coordinate would be this guy down here. And the x value from our first coordinate, that's x1. And the x value from our second coordinate is this guy here, x2. So again, if I wanted to find the slope between these 2 points, what I need to do is subtract the two y values. Now I'm going to start with 8 and subtract away 3. And then for the x values, I need to start with 6 and subtract away -2. Now, it's real important that you keep the order correct. And if you start with this 8 and subtract 3 from it in the numerator, then you must start with 6 and subtract -2 from it in the denominator. When I simplify this, I get 8 minus 3 to be 5, and 6 minus -2 to be 8. We would say that the slope of this particular line that connects these 2 points is 5/8. We have a rise of 5 and a run of 8 in order to reconnect these 2 points. So that's a little exercise in the mathematics behind calculating slope. Let's see how we can use that in a real-world application. Let's consider a tank of water that's being filled at a rate of 2 gallons per minute. It was half full when the water started filling it, and it has a capacity of 100 gallons. How long will it take to be full? Don't forget that rate is another term for slope, right? Average rate of change is the same thing as slope, and we have 2 gallons per minute here. We were told that it was half full when water started being when water started filling it. So if it was half full, that's our starting point. We can use that as our y-intercept. We have an end result, or a target, of 100 gallons. We want this calculation to come out to be equal to 100 gallons. And I think with those 3 points, our target, our starting point, and our slope, we should be able to write a function in order to find this answer. So let's think of this. If our target, y, is equal to the slope times x plus our starting point, y equals mx plus b, then 100 should equal 2x plus 50. Again, our target of 100, our slope of 2, our starting point of 50. We can do the math here. We can subtract 50 from both sides. We could then divide both sides by 2, and that tells us that x must be 25. Now, in terms of our units, we were talking about 100 gallons is equal to 2 gallons per minute times x plus 50 gallons. This x value is the length that it would take to be full. So when we're talking about a length of time, this is 25 minutes. It takes 25 minutes to go from 50 gallons to 100 gallons. And we got that by using the slope and the intercept of this equation. Let's take a look at another one. And this time we'll put a graph with it. Let's draw this graph this way. The tank of water is being emptied, so we know we started at 100 gallons. This one's here at 0, 100. That tank that we were dealing with before is now being emptied. So we're starting at 0 time and 100 gallons. After 6 minutes, 1, 2, 3, 4, 5, 6. After 6 minutes, 30 gallons were evacuated. So we lost 30 gallons. If we lost 30 gallons after 6 minutes, how many gallons were left? You got it, 70. The question becomes, when will the tank be empty? Let's start off by creating the slope between these 2 points, because I'd like to have a starting point, which I have. I'd like to have a slope. And so what we have here is a sample calculation. We started with 100 gallons and we reduced to 70. So those are my y values. We have x values starting at 0 and moving up to 6. So when using our slope calculation, we would subtract 70 minus 100 and 6 minus 0. 70 minus 100 is negative 30, and 6 minus 0 is 6. So when we simplify negative 30 divided by 6, we're left with negative 5. And our units of measure here have to be gallons per minute because we're reducing by 5 gallons each minute. Now the question becomes, when will the tank be empty? And to think of that, the tank would be empty when its total is equal to 0. So if we're using our equation y equals mx plus b, our total has to be 0. Our m value we just calculated to be negative 5. Negative 5 times x plus b, our starting value was 100. So 0 must be equal to negative 5x plus 100. Let's subtract 100 from both sides. Negative 100 equals negative 5x. Divide this by negative 5 on both sides, and we're now left with x equals 20. X is our time. It is the time that's passed since we've pulled the plug on this barrel and we started emptying the water. It would take 20 minutes to empty this entire tank. Whereas it took 25 minutes to fill the tank half full from 50 gallons to 100 gallons, it only takes 20 minutes to empty the entire thing. Let's take a look at another example. After driving for 1 hour, you are only 10 miles from home, whereas after 2 hours, you are 40 miles from home, and after 3 hours, you are 120 miles from home. What's your average rate of change for the first hour, for the second hour, the third hour, and what was your average rate of change for the entire trip? Well, let's plot some points here and see if we can figure this out. I'm going to put time down along the x-axis. So time, this is my x-axis. And for my y-axis, I'm going to put distance. So this is the distance we've traveled in a certain amount of time. And I'll label this 20, 40, 60, 80, 100, and 120 miles. And as far as our time goes, there's really only 3 values that I'm interested in, 1, 2, and 3 hours from the start. So at the start, let's consider what our coordinate would have been. At the start here, we are 0, 0. 0 minutes have passed, and we've traveled 0 miles. So that's why we're starting here at 0, 0. After 1 hour, you were only 10 miles from home. So maybe you got yourself into a traffic jam, or it's slow moving when you left your house. We only went 10 miles. After 2 hours, you are now 40 miles from your home, and after 3 hours, you are 120 miles from your house. So let's answer these questions. What was your rate of change for the first hour? We're going to call this M1. That's our rate of change for the first hour. Then we'll call M2 the rate of change for the second hour, and we'll call M3 the rate of change for the third hour. Let's calculate M1 over here off to the side. M1 would be this coordinate, which was 110, compared to the original coordinate, 0, 0. So x2 and y2 will be used first. So y2 was 10, and x2 was 1. y0 was y1 was 0, and x1 was 0 as well. So if I were to simplify this slope, I have 10 minus 0, which is 10, 1 minus 0, which is 1. We traveled 10 miles per hour on average. And that makes sense. We traveled 10 miles, and in 1 hour, we can see that we traveled on average 10 miles per hour. For the second slope, we're looking at the coordinate 2 and 20. I'm sorry, it's 2 and 40. And you might be able to figure this one out in your head. How much distance did we travel in this latest hour? Well, that's 30, and we traveled that in 1 hour's time. So we should average 30 miles per hour. Let's see if the math supports that. We'll have 40 minus 10 divided by 2 minus 1, and that's absolutely true. We have 40 minus 10, that's 30. 2 minus 1, that's 1. We have 30 miles per hour for that second leg of the trip. For that third leg of the trip, it looks like we started making up some ground. We were able to get up to speed, and we covered a lot of distance in that last hour. So what we have here is the number 120 minus 40. Divide that by 3 minus 2, and that comes out to be a whopping 80 per 1, or 80 miles per hour. It looks like we were speeding at that point. So for that first leg, we had a slope of was 10 miles per hour. The slope here the second time was 30 miles per hour, and then we increased to 80 miles per hour. Again, 10 miles per hour, 30 miles per hour, and then finally 80 miles per hour. Our rate of change changed throughout the entire trip. But what is our average rate of change over the entire trip? What is the average rate of change from start to finish, or start to our final point here? Well, we can find that too. M of 4, we'll call this, is equal to 120 minus 0 divided by 4 minus, oops, not 4, I'm sorry, 3 minus 0. And that comes out to be 120 divided by 3, that's 40 miles per hour. So even though we were able to make up some lost ground here, driving 80 miles per hour, what we found is that on average for this entire trip, we only managed 40 miles per hour. And I think someone could make the argument that it's just not worth it trying to make up for lost time, If you're driving 80 miles per hour for an hour, you stand a chance to pick up a pretty massive speeding ticket for doing so, and it really doesn't have that great of an effect on the overall average speed because you're still only averaging 40 miles per hour. If you had slowed down to take followed the speed limit, that probably wouldn't affect your overall average rate of speed all that much. Now you have the tools and techniques that you can use to answer that question if you wanted to. Before we finish out the video, I do want to take a look at the ability that we have to calculate slopes between 2 points in a table. Now, given this table below, we need to find the average rate of change between f of 3 and f of 9. So here's 3 and here's 9. Here's f of 3 and here's f of 9. This is exactly the same as a y value. Y is often used to replace f of x and vice versa. So if I wanted to find the slope or the average rate of change between these two, the math would be just the same. I'll take 30 and subtract 20 and then divide 9, subtract 3. This comes out to be 10 divided by 6, or when we reduce, that's 5/3. Our slope is 5/3. Now, if I move on to the second set and I find the average rate of change between 0 and 6, so f of 0 and f of 6, I get this calculation. The slope is equal to 25 minus 15, and I divide that by 6 minus 0. Well, that 2 comes out to be 10 divided by 6, or in other words, reduced to 5/3. And so we see that these two slopes are the same. Out of curiosity, I'd like to see what happens if I calculate the slope between the starting point and the ending point. So let's say 30 minus 15 divided by 9 minus 0. Well, this comes out to be 15 divided by 9. And I know the numerator and denominator can both be divided by 3. That reduces to 5/3 as well. All three of these slopes are calculating the exact same. They are the same throughout the entire function. So we would say that the slope is constant. It's constantly the same. And what did we say at the beginning of our notes today about slopes that are constant? What sort of function does this create? Well, if we look at this, we see that it is a linear equation that is a function of a constant slope. So if the slope is constant, what kind of function is this? This creates a linear function. And we'll talk more about those tomorrow in class. Please let me know if you have any questions. I'll be happy to help.